Hi, we're a research group from Princeton University's Center for Information Technology Policy. We are proposing IoT Network Monitor, a helpful and intuitive tool for users to visualize the vulnerabilities in their IoT devices at home. We are proposing 3 features, which then can be generalized to cover a variety of different privacy and security concerns. First of all, we detect default passwords on devices and change them, and alert the users. Secondly, we detect whether your devices are leaking sensitive personal or identifiable information. And third, we look for anomalous behavior in case a device has been controlled by a botnet. We have 2 layers. We have a program that's running on essentially a router, which is a Raspberry Pi, and we also have a front end, which is an interactive interface for users to look at the actual vulnerabilities.
The first feature we propose is an IoT botnet detection system. Essentially, we want to identify whether or not devices on the local network are part of a larger IoT botnet and are sending attack traffic associated with a denial of service attack. The way this works is that a variety of machine models that have been trained on real attack and real samples of normal IoT data analyzes each packet that leaves the local network before it accesses the wider public internet. And by being able to classify whether or not a packet is good or anomalous, we can determine whether or not an attack should be allowed to leave the network or whether or not it should be blocked.
Default passwords of IoT devices have enabled the construction of botnets, resulting in large distributed denial of service attacks. Our tool scans your home network for devices on the SSH and the Telnet port with default username and password combinations. When devices with default username and password combinations have been detected, the tool changes the default passwords to a randomly generated string and notifies the user.
The third feature of the IoT Network Monitor is a privacy feature, which scans the transmitted packets for potentially sensitive information that may be leaked from IoT devices in the home network. This is done by classifying packets as either being encrypted or non-encrypted, and then analyzing the unencrypted packets for potentially sensitive medical information, first names, or personal identifiable information. If a packet is found to be sending sensitive information, it is sent to the user interface to display to the user that this information is being sent.
This is the user interface of the IoT Network Monitor. From the Connected Devices dashboard, users can visualize the state of their IoT devices according to 3 different criteria: passwords, privacy, and behavior. The UI is designed to be user-friendly, so each panel displays one device and it is updated as traffic is recorded by the router. In order to get the current state of the devices on the network, users can click the Update button. Here, we can see various vulnerabilities detected on the network. In the case where a device is shipped with a default password, such as the iHeart blood sugar monitor, our tool detects and changes the password to a random 12-character string that the user can access from the dashboard. This Whiting's blood pressure monitor is sending sensitive information about the name of the user in plain text. Clicking the arrow button reveals relevant information regarding how to address this vulnerability. In this case, disconnect the device and contact the manufacturer. If a device is sending attack traffic, the user is instructed to disconnect the device from the network.
Just to recap, we are providing a new platform for security researchers and device manufacturers to be able to ensure that consumer home IoT networks are secure from cybersecurity vulnerabilities. This is done in 2 ways. Our intuitive, friendly user interface allows consumers to really understand IoT security in a whole new way and learn what sort of actions they can take in response to a variety of new threats. And our software layer at the router brings into the spotlight a variety of cutting-edge techniques ranging from machine learning for anomaly detection to Mirai-inspired security analysis for password protection to a variety of network traffic analysis techniques for understanding confidential information leaks. This framework can be extended both in the front end and in the back end to a variety of different vectors, and we invite the rest of the cybersecurity community to help us move in this endeavor. Thank you.